Hi, welcome to this STAIR Tailored. My name is Sarah Powell and I'm at the University of Texas at Austin. And today we're going to solve two-step equations that have a subtraction operator symbol. And by that I mean this minus sign right here. And we're going to use everyday materials. We're going to use some cups and counters to solve these problems. So the two problems we're going to work on today are 2x minus 4 equals 2 and 5 equals 3x minus 7. Wow, that's a mouthful. Let's go ahead and get started. So here is my first problem that I'm going to solve. Remember, it's always very smart to have the abstract presentation of the number presented for students. And I've already started this problem, so I have 2x. That means I have two sets of x. Here, my plates or my cups represent x, and I have an x written on both of them. You don't have to do that, but it's kind of helpful to do that. Now, I need to set this up by subtracting 4, but I don't have 4 to subtract. So what I can do is bring in 0 pairs, and I'm going to bring in these two color counters right here, kind of move them there, to get to the point where I have 4 positive to subtract. Because notice that is a positive 4. It is not a negative 4. This is minus positive 4. So I'm going to use my 0 pairs to get to the point where then I have positive 4 to take away or subtract. And yay, we got there. So now I'm going to go ahead and subtract my positive 4. So that's why we can use these red counters to show 2x minus 4. Now on that side of the equal sign, we have 2, and that's a positive 2, so I'll use the yellow counters there to show my positive 2. Now we want to isolate the variable. That means we want to isolate these x plates there, and I can do that by using 0 pairs. So I'm going to create 4 0 pairs on this side of the equal sign. But if I do anything to this side of the equal sign, I also have to bring in 4 positive on that side of the equal sign. We always need to balance both sides of the equal sign. So now I'm going to remove my 0 pairs, and I don't have to remove any 0 pairs over here. So we have 2x equals 6. Now we're not finished with the problem just yet because we want to figure out the value of each of these x's. That means I'm going to take my constant and divide them into 2 equal groups. And I can just go ahead and show that just like that. So here, each x has a value of 3. Now let's go ahead and set up this next problem. I'm going to remove all my plates and all my counters. And I'm going to start here with 5. So I've got 5 counters. I'm going to use the yellow side to represent a positive 5. And here now I'm just going to use 3 little post-it notes that each have an x written on them. That's going to represent my 3x. And I have minus 7. And as we talked about last time, well, why do we end up using those red counters? We showed the example here of what it means to actually take away positive 7, and we can represent it in this way. Now I want to isolate this variable, which means removing this constant. So now I'm going to create 7 0 pairs on that side of the equal sign. So I'll use my yellow counters just like that. And it's hard to see them, I kind of scoot them just like that. But remember, whatever I do to one side of the equal sign, I also have to do to the other. So 1, 2, 3, 4, 5, 6, 7. Now I think what would be helpful here right now is to think about the notation that we often use when solving this problem. So I'll do it just right here, okay? I usually draw a line down to balance the two sides of the equal sign. To remove this constant, I add 7, and then I do that to this side of the equal sign as well. And what do you notice? This is exactly what we just did. I had my 5 and I added 7, and I had my 7 that were really negative, and I added 7 positive to have those equal 0, right? So now we have this set up as 12 equals 3x because I remove each of these 0 pairs. So it's always important that anything that we do with manipulatives also matches the abstract procedures and representations that we use to solve the problem. So now I'm going to divide each of these sides by 3 to figure out the value of a single x. So I'm going to take my 12 counters and equally distribute them. So there we go. And finally, we can see that the value of each x is 1, 2, 3, 4, and that's positive 4 because these are yellow counters, not red counters. So those were some ways that we can solve two-step equations that feature what were we focusing on there? A subtraction operator. And I hope you'll look at some of our other STAIR tailored sessions to see how we can use cups and counters to solve lots of different problems.